Look down at your hand right now, just for a second. Whatever shade it is, pale enough to catch a sunburn in 20 minutes, or dark enough to shrug off a whole afternoon outside that color has a story. And it's not the story you probably think it is. It's not random, it's not decoration, it's the visible record of a negotiation your ancestors ran with a single indifferent star. 93 million miles away, for over 250,000 years. The sun didn't do this on purpose. It doesn't have opinions about skin, or preferences, or a favorite. It just radiated the same relentless energy at every human population on the planet. And every population had to answer back, biologically, or lose the negotiation entirely. And by the end of this video, you're going to look at that same hand completely differently. Here's where it gets strange immediately. As far as the evidence currently shows, every human being who has ever lived, if you go back far enough, had dark skin. Not most, not the majority. Essentially all of them. Every civilization you've read about, every myth, every face carved into stone, all of it traces back to one dark-skinned population in Africa, roughly 300,000 years ago. There were no pale humans anywhere on Earth. That idea didn't exist yet. So something happened, something powerful enough to rewrite the surface of an entire species, more than once, on more than one continent. This is that story. Skin isn't packaging. It's your body's largest organ, and one of its most important jobs is standing between your DNA and the sun. The sun fires ultraviolet radiation at Earth constantly, and of light is aggressive. It breaks chemical bonds, damages DNA, and left unchecked, causes the mutations behind melanoma, one of the deadliest cancers there is. Melanin is the pigment behind skin color, and in the most literal sense, it's sunscreen your body makes itself. More melanin, darker skin, better of protection. Near the equator, where our species began, that protection wasn't a preference. It was close to mandatory. Natural selection doesn't run on taste, it runs one relentless calculation, over and over. Across every generation, did this trait help you survive long enough to reproduce? Under equatorial UV, dark skin answered yes, every single time, with no exceptions worth mentioning. And there was a second reason, one most people have never heard. UV radiation doesn't stop at your skin, it also breaks down a molecule in your bloodstream called folate, essential for early fetal development. Too little folate in early pregnancy can prevent the neural tube from closing properly, with consequences ranging from severe birth defects to miscarriage. So under an equatorial sun, dark skin was doing two jobs at once, shielding DNA from cancer-causing damage and shielding folate to protect pregnancies. Two independent survival pressures arrived at completely separately, pointing at the exact same solution. Starting somewhere between 50 and 100,000 years ago, the exact window is still debated among researchers. Human populations began drifting out of Africa, not in one dramatic exodus, just generation after generation, moving a little farther than the last. Middle East, then Europe, then Asia, eventually the Americas. And as they moved north, the sun itself didn't change. What changed was the angle it hit them at. Near the equator, sunlight strikes the ground almost straight on. Near the poles, it arrives at a shallow slant, which means it has to travel through a much thicker slice of atmosphere before reaching skin and atmosphere filters out along the way. Add long winters and gray overcast skies for months at a time, and the UV environment in northern Europe or Siberia isn't just weaker than equatorial Africa. It's a fundamentally different problem to solve, which meant the exact same melanin that was essential in Africa became a liability somewhere else. Not because of cancer that risk dropped sharply at lower UV exposure. The real problem was a molecule that barely got mentioned so far, vitamin D. Your skin manufactures vitamin D using UV light as raw fuel. And vitamin D isn't optional, it governs how your body absorbs calcium. And without enough of it, bones fail to mineralize properly. In children, that produces rickets. In adult women, it can soften the pelvis badly enough to make childbirth dangerous. Sometimes fatal. Skin can't selectively let in good UV and block bad UV, it just blocks, or it doesn't. So heavily melanated skin in a low UV environment quietly started costing lives, generation after generation, through vitamin D deficiency alone. And evolution, which doesn't care about anything except what keeps offspring alive, began favoring the opposite trait it had favored in Africa. Mutations that reduced melanin spread, slowly, Because slightly lighter skin meant slightly more vitamin D, slightly stronger bones, slightly better odds of surviving childbirth. Multiply that small edge across thousands of generations, and skin tone drifts. For a long time, that was assumed to be a slow, steady process, populations gradually lightening over hundreds of thousands of years as they pushed north. It was a reasonable assumption, built on the evidence available at the time. It also turned out to be wrong. And the correction came from a source nobody expected: ancient DNA. In 2018, researchers sequenced the genome of a roughly 10,000-year-old skeleton found in Britain, known as Cheddar Man. The DNA-based prediction about 76% confident, worth being upfront about, since this is a probabilistic reconstruction. Not a photograph pointed to something almost paradoxical by modern assumptions: dark to black skin, dark curly hair, and blue eyes. A combination we don't expect, because we've come to associate blue eyes with very pale skin. But 10,000 years ago in Britain, that link hadn't formed yet, meaning early European hunter-gatherers lived at northern latitudes for tens of thousands of years without dramatically lightening. The genuinely pale skin common across northwestern Europe today appears to have spread widely only in the last 6,000 to 8,000 years. Out of a 300,000-year species history, that's under the final 3%. Something accelerated this dramatically, and it wasn't just moving farther north. That accelerant was the Neolithic Revolution, the shift from hunting and gathering to farming. Hunter-gatherer diets were naturally rich in vitamin D, fatty fish, organ meats, shellfish, all among the richest dietary sources of it that exist. Farming diets were built around grain wheat, barley, cereals which contain almost none. So the moment agriculture spread, populations lost their dietary backup source of vitamin D right as they needed skin-synthesized vitamin D more than ever. If your skin was still fairly dark and your diet no longer helped, that gap had to be closed somehow, and it was closed the only way biology had available. Even a small reduction in melanin became critically valuable. Fast. And farming communities were larger, denser, and more interconnected than scattered hunter-gatherer bands of a few dozen people, which meant a beneficial mutation could now spread through thousands of descendants in a handful of generations instead of crawling slowly between isolated, scattered groups. Diet collapse plus population density didn't just continue the existing trend toward lighter skin, it hit fast forward on it hard. Here's the detail that should stop you completely. Skin pigmentation isn't controlled by one gene, it's polygenic, shaped by dozens of genes working together. Genes that influence how much melanin gets made, what type, and how it's distributed inside skin cells. And when East Asian and European populations independently evolved lighter skin, they didn't arrive there through the same genetic changes. Largely different genes, different mutations, different molecular paths, same outward result. Natural selection didn't copy an answer from one population to another the way you'd copy a solution from a classmate. It solved the identical problem completely from scratch, more than once on separate continents, with no shared genetic shortcut connecting the two solutions at all. When evolution reinvents the same answer independently, more than once, that's about as strong a signal as biology ever gives you that a trait genuinely mattered for survival. Lighter skin was never one lineage's story passed outward. It was the same pressure. Asked of two separate populations, answered twice, independently, correctly. One more genuinely strange footnote while we're here: every person alive today with blue eyes descends from a single individual, one mutation, somewhere near the Black Sea roughly 6,000 to 10,000 years ago. Before that person existed, every human eye on Earth was brown. No exceptions. All the way back. A trait we treat as ancient and fixed, something people casually assume has always existed, is in geological terms brand new, younger than farming. Younger than most of the civilizations you learned about in school. So let's put the full picture together. Dark skin isn't primitive, and it isn't a starting point evolution moved past the ancestral baseline. The configuration our entire species carried for the overwhelming majority of its existence. Lighter skin is the newer variation, the modification, the exception, not the other way around. And neither is better in any absolute sense. Light skin in equatorial Africa isn't an upgrade, it's a liability. More cancer risk, more folate destruction, worse odds of healthy offspring. Dark skin at high latitudes with no dietary backup isn't a disadvantage by accident, it measurably cost lives through vitamin D deficiency. This was never a hierarchy. It was the same sun asking a different question depending on where you stood, and evolution answering honestly every time. For most of human history, that answer was read as something it never was: proof of rank. Proof of difference that mattered beyond the biology itself. Entire hierarchies, entire systems of power got built on top of a trait that is, underneath, a OOV dial recalibrating itself to latitude. It never carried that meaning at the level of the actual mechanism, and the science has never supported it carrying that meaning. It's a calcium problem, a cancer shielding problem, a folate problem, written onto skin by latitude and diet, not by worth no exceptions, no gradient of more or less human anywhere in the biology. Look at your hand one more time. Every shade of human skin alive today, from the palest to the darkest, descends from that same original population standing in the African sun. Your specific color is a precise, inherited record of exactly which latitudes, which diets, and which skies your ancestors survived under, written in melanin, one generation at a time, updated slowly, honestly, without ever asking anyone's permission. So here's the actual question worth sitting with. If your skin is a message from your ancestors about where they had to survive, what do you think it's telling you that you never bothered to ask?